Good afternoon, everyone. Just giving two more minutes.
I was just about to say, but me not understand. Look, that class not keep tonight. There are only 4 of them. I was just about to unmute to say, Miss, class, you did postpone class? My
Not
gosh.
to my knowledge.
All right then. So 2 more minutes then. All right, no problem.
2 more minutes. So we are ready. Good afternoon, everyone.
Miss.
Good afternoon. I'm sure to put up the Bible verse, you know, where 2 or 3 are gathered in my name, there I am in the midst of them. Right, so we're going to start off this afternoon. I'm just going to volunteer. And I'm still declaring that he's in the midst because my screen is now freezing and I am at work all of a sudden. Anyways, any volunteer?
Needs to do what?
Sentence prayer. That's what we start
Okay.
off with. Nice.
Dear Lord, as I come before you today, I ask for your guidance and for your protection. Hurry the footsteps of those who are coming and those who can't make it, Lord. I hope that you guide and protect them. Help this class to be successful. In your name I pray, amen.
Amen. All right, so this is a revision. We're doing some revision now. Thank you very much for that prayer. And I repeat, for where 2 or 3 are gathered together, there am I in the midst of them. So we're going forth in faith and we shall achieve, right? We're going to be doing differentiation. And this topic started weeks ago. Well, last week we went further into it. And the objectives we will be looking at this afternoon is that by the end of the class, students will be able to define the derivative of a function, use constant, power, and the chain rule to differentiate, discuss in the group how the intuitive approach can be used, and I leave this blank for a reason. So the connection we like to come to is how to put both approaches together when we're talking about the derivative of a function and the intuitive approach when we're talking about limits, okay? So the derivative of a function can be geometrically interpreted as the slope of the curve of the mathematical function plotted as a function of x. Any question on that statement? Do you agree, disagree, or have a suggestion based on that statement? So we're all on board, right? All right. So it's a slope of the curve of the mathematical function f of x plotted as a function of x. So here we have two pictures, right? On the left, we're showing the derivative where the function is evaluated at x equal a. And what do you observe from this picture here? Class? Let me see who is on. We're making the connection here to what we're doing in relation to finding the derivative graphically, right? So
Yes, Miss. Miss, which one of the graphs? The
to
one
the
in
left,
pink?
the one in pink, right? So we're saying f of x is evaluated at x equal a, which gives the slope of the curve x equal a, right? So when we're here to find the slope of the curve, this is what it will look like. We would have also been exposed to finding the slope of linear functions, linear graphs, right? You would know that before. This would take on prior knowledge. Rise overrun, does that ring any bells? And what does
Yes,
that
Miss.
include?
Gradient.
The gradient. So once we mention rise over run, we understand what we're talking about. We're talking about the gradient. So it's the same thing we're doing here when we're talking about finding the derivative of the function. Right? It's the same thing we're talking about when we talk about finding the derivative of the function. Okay? So we're just making the connection here. So let's move on. So we would have known for the linear equation or the linear function to say that the linear graph or the function to say that it would be the change in the y divided by the change in the x value. And we can see that being demonstrated here on the right, right? So you can recall the equation of a straight line where the slope here is refers to as m, right? What is the equation of the straight line? Do you remember?
Y equals mx plus c.
Right. It's the same. We're not going to change what you have learned before. We're building on prior knowledge, right? So it's the same information, same thing. It's just that it is represented differently. So the derivative is found at different points along the curve, okay? So if y is a function of x, then the derivative of y with respect to x is written as the same, what we're calling the dy over dx, right? It is a new function that is called the gradient function. So to obtain the gradient function from a polynomial function of the form ax to the n, which we were introduced to already, right? We simply multiply the exponent. We're talking about how to find it. But what is your take so far? Are you seeing the connection here between what we're doing, the derivative and the gradient?
It's a little.
A little, that's fine. Thank you very much. So remember that it is easier for you to find the gradient of a straight line. At least you can see it. It is very obvious, right? Are you seeing my screen?
Yes, miss.
Clearly? Okay. So when you see let me ensure that you're seeing the graph, right? You're seeing the graph. So for the straight line, it's easier for you to look at it and do the rise over the run. You choose the change in the y values and you divide it by the change in the x values, right? And then you will find the gradient. However, for a curve, it is much different, right? Because you don't have straight lines. But it doesn't mean that you cannot find the gradient at a point along the curve, right? A curve has a variable gradient, some persons may say, right? Unlike that of a straight line, which is fixed, the gradient of a curve is defined by at any given point on the curve. The gradient of a curve is at a point which is defined as a gradient of the tangent to the curve at that point, right? So that is what you're finding
Repeat,
when you're
miss.
talking about the gradient of a curve at a point is defined as a gradient of the tangent to the curve at that particular point, right? So it's the same principle as in when we're doing the straight line, when we're finding the gradient of the straight line, right? So if you are given a curve, what you need to do, and they ask you to find the gradient at a point, you may draw a straight line that just touches the curve at that point, and then that would be the tangent to the curve at that point, right? And then from there, you can calculate the gradient of the tangent using the appropriate method, which would be the rise over run, right? Which is similar. This is the same thing what we are doing. Let me share with you an example. Mhm. All right, look at this picture. Are you seeing what I'm saying? The gradient of the tangent at the point. So the tangent is just, it's at one point. It doesn't run along with the curve. It doesn't, you know, it just touches it at that one particular point. And then you're able to find the gradient of that at the point for the curve, right? So it's similarly, we are finding the derivative. So let's get back to it. We were introduced to this topic. It's just, I'm just providing you additional information so you can make further connection, okay? Let's go back to our regular. And at any point in time, if you have a question, you can stop me, right? So we were introduced to the form ax to the n, where we see how we obtain the gradient function from a polynomial function, right? We have it in the form, and what we simply do is to take the exponent and we multiply the exponent by the coefficient of x, right? And then to the exponent, we subtract 1. Remember that from last week and the week before?
Yes, miss.
Right. So now we're going to put it into practice. So we're going to evaluate the derivative. Oops, showing you what I should not. Hope you're not taking a picture as yet. Let's evaluate the derivative of the following. Dx over dy, we're evaluating 3 over x. What would that be? Any suggestion?
Miss, would it be negative 3x to the minus 4?
How did you get
Negative
that?
3x minus 4.
How did you get that? Let me see if I
Miss,
can annotate. Talk to me.
oh, so when you have a fraction like this, you can write it as in exponential form. So it would be x minus 3 because the 3 is positive. I think it will change to a negative number. So it would be x minus 3, and then and the minus 3 becomes the power, and the minus 3 would become the coefficient of the power, which is the x, and then you'd minus 1 from the power, and minus 3 minus 1 is minus 4.
Okay. It sounds very much familiar, but I would like to know what to type. What step by step now? This is who? Tanil?
Yes, miss.
Right. What's the first thing I should type right here if I'm sharing the response with the classmates?
Okay, miss. So you can just put x minus 3.
X minus 3 or x to the or 3 x to the power of -1. You're rewriting the fraction. Which one is it?
Because that's not what I did.
All right, tell me what you did. I'm gonna type what you did. 3.
Because I put -3 as a power.
-3 as the power.
Yeah.
So what is the base? So are you saying 3x -3? That's what you're saying?
No, I just have x as a base and -3 as a power.
Okay. And your answer is, your solution is? Let me write down your solution so that we can discuss it.
So I have x and I put -3 as a power. And then I multiply the -3, the coefficient of x. And then I subtract 1 from the power.
Thank you, Tanil. May I hear from the rest of the class? Do you agree? Do you disagree? But no neutral.
Everything
And
is x with the power being negative.
go again.
This is 3 and I have negative x as the power. The -1 x.
Okay. All right. So I'm going to remove this part and leave Tanil's working out right there. Let's put another working out. Let's see. Okay, go Aniki. Let me hear what you did.
Base 3 and then you have negative x.
Like that?
Yes, miss.
Okay.
It's going to be negative 3 raised to negative 8.
You're breaking up. You're breaking up. Go again.
So I say it's going to be negative 3 raised to the power of negative 2x.
Okay, negative 3 raised to the power of negative 2x.
Yeah.
Negative 2, which is, okay, something went on right here. This is what you're saying. No, this is not what you're saying. So you're saying 3 raised to the power of negative x, or are you saying, is that what you're saying? Talk again. Think about it.
Negative 3. Yeah.
Negative 3x. So let's start again. So it is 3 raised to the power of, you said negative x, or is it 3 times x? Okay, cannot use the same x. Raised to the power of negative 1. Which one is it? This one? Aniki?
Yes, ma'am.
Okay. All right. So that means this will be different. So you're saying this will be negative 3, right?
Yes.
X raised to the, you said negative 2?
Yes.
Okay. That is your final solution?
Yes, miss.
Okay. Anyone else? Thank you, Aniki. Anyone else? Okay. Let's discuss the two responses received so far. All right. So we have 3 divided by x, the fraction, right? And I see where Tanil, why did you raise 3x to the power of negative 3? Why did you raise x to the power of negative 3?
Miss, I think it's based on what I did last week when I had the fraction. So that's why I think that the x would become in the numerator and then the 3 would become the power of x.
Okay. And based on what Aniki has presented, she's presenting the reverse. Why is that, Aniki? Can you share the reason with the class why you're presenting the opposite as to what Tanil is presenting? All right. So, all right, Tantan, let's work with you. And
it was the y one.
which one?
The y with the little stroke at the
The one with the stroke at the top.
Yeah.
Okay. All right. So let's clarify this. Thank you, Aniki Anthony. When we have the what is 3 over x? This is read as, another way to write it is 3 times x to the negative 1 to the raised to the power of negative 1, saying that it is in the fractional form. It is 1/10, right? So it is raised to the power of negative 1, right? So I do agree with Aniki, but I think there's another reason out there which we need to share with each other, right? Okay, and continue working out. Anyone else has a different idea?
Miss, I understand what you're saying.
Right, so I'm going to clear it and scroll down. All right. So you want to restate your position then, Taniel. So in this question, we were working it out and something came to mind. What is the error in this question, this response? So I was
Negative 1 times 3 is negative 3.
Right. And that is it, Aniki? That is the only error?
Yes, yes.
Right. So we are confirming to say that the solution to this derivative is negative 3x to the power of negative 2. Is everyone on board? Go again?
That was correct.
Yes, you were. You were correct. All right, so let's move on to the second question now. We're differentiating 3x raised to the power of 5. What is the solution for this one? So we can go quickly because remember this is a revision. And I have on this side the different rules to remind us as to how to approach the questions. Okay.
Miss, would this be 15x to the 4th power?
Girl, Tantan, you ready for exam tomorrow, man? We just have to tie in those little loose ends, right?
Yes.
Nice. Good practice. So is everyone seeing that? What step was taken? What step did Tanil take to come to that solution? 15x raised to the 4th power. Can someone describe to me, except Tanil?
We are going to multiply for x.
Going to multiply what, Aniki? The coefficient, the exponent by the coefficient of the x, right? And then what do you do next?
You subtract 1 from the power.
The power. Is everyone on board? Tati, as in Davidson, are we on the same page?
Yes, miss.
Nice. What about green?
If you get the other one, miss,
Repeat your question, Kasana.
the one, where did you get it?
Which one? Guide me. Right here?
If you know, say something more like you might have n take away one something, but what 2, 1, miss right there, so don't there, so what it be then?
Right here. Okay, let me tell you what is happening right here. Okay. So let's rewrite it. Let's rewrite this step by step. So the first step is that rewriting this problem, it would be 3 times x to the -1. Do you agree? Just rewriting the problem here. Do you agree?
Yes, miss.
All right. And then we are differentiating now. How do you differentiate when you have 3x to the -1? What is the next step that you do? So this would be the first step. And here we're moving on to the second step. What is it that you do? You multiply the coefficient. So here we go. Sorry for using 2 signs at the same time. Or what I could have done is just copy this here and put it here. Let's go to the next row. So this would be 3x, right, to the -1. So here, the first thing we did was to separate the coefficient, right? 3x, separate the coefficient. Next, what we did was to multiply the coefficient 3 by the -1, the exponent by the coefficient. So here we get the -3, right? And what's the next step? Based on the power rule, what is the next step? What is it that we do next? What do we do to the power or the exponent? Kesana?
With your -1.
-1. So you already have a -1 and we're minusing another one. So that will give you a -2. So we're all clear on that now? You're clear now, Kasana?
Yes, miss.
Right. So let's move on to the other question which we were evaluating. We were saying, Tanil gave the response to say that the solution is 15x raised to the 4th power. And I was asking, is there anyone not on the same page, or is there anyone disagreeing with what Tanil has given? Or is there anyone not seeing the solution? John Mark, are we clear?
Miss, I just reaching. I just
All
reached.
right. All right. Breeze off, son. Take time and breeze off. All right. Let's go. Nathaniel, all are we seeing? Are we understanding how we got the 15x raised to the 4th power?
Miss.
Repeat, yes or no? Repeat that.
Yes, miss.
Okay, nice. So let's move on. So we're applying the power rule. We've applied the constant multiple rule. So you see what I did here was to put the constant. We just recognizing, identifying the constant to say that the power, the coefficient and the exponent will multiply by the coefficient here. That's how I get the -3, right? So you have the power rule, we have the constant, and we're moving on. Let us try this other question. What is the derivative of 8x raised to the 4th power?
32x to the 3rd power.
Also, Tanil, the question didn't even reach there 2 seconds good. Is everyone, Javia, are you seeing the same response as Tanil?
Yes, miss.
Okay, easy business, easy cheesy. So John Mark, are you seeing the same response, the same solution? I know you're just reaching out, but I don't want to leave you behind. Yes?
Yes, miss. Yes, miss.
All right, nice. Nice, everyone. Sir is ready. Listen. Ready, ready, ready. So here we go. So we have 8 and we have 4x raised to the power of 4. And then what we do is 4 times the 8 gives us the 32. And what is left is x cubed, right? Because we're subtracting 1 from the power of 4. So let's try question 4 now. Oh, okay, I gave away that one. Can't hide it again. So what is the derivative of sin? The sign 2x minus 3. What did we learn?
Miss, were you supposed to factor out derive the 2?
Is everyone comfortable with this one? If we repeat it, remember sir did the jingle. Say sine x, the derivative of sine x equal cos x. Derivative of cos x is equal to negative sine x. That is the rule, and that is the rule we're following. Right? So wherever you see a question to evaluate a derivative and you see sin immediately, what are you replacing it with?
Cosine x.
Cosine x.
Cos.
Cos x. Whatever you call it, as long as you write it on your paper, right? Nice. Let me see if I can, without showing you the solution this time. Let's try number 5. Time is
Miss, for
going.
number
Let's go.
4, Miss, for number 4, one's supposed to derive the 2. So it'll be 2 cosine 2x minus 3.
Nice. Somebody's paying attention. Tell me what to write.
2 cosine open bracket 2x minus 3.
And I do agree. So it means that, guess what? We are learning and we're paying attention. So when this come on CAPE exam, full marks. Isn't that so, Tantan?
Yes, Miss.
Nice. So let's go. Question 5. And before we move on to question 5, why didn't we write back? Why didn't we multiply 2x minus 3 by the cosine? Why didn't we put it as a coefficient there? Can someone else except Tanil share with me their idea?
This is not like a rule, miss. They differentiate the inside and they differentiate the sine x.
Okay. You're getting warm. Continue. Come on, man. Don't lick near the nail. I want you to hit the nail on the head. Continue.
Miss, we done, miss.
You know, man, you not done yet. Pick up back the hammer. We're not done yet, Matthew. Long time I don't hear from Matthew. Matthew, long time I don't hear from you. So you are the next best friend in class, okay? So don't move anywhere. Don't go anywhere. Always keep a mic open. Ready, Matthew? So what else did Sir say when we are differentiating? Why didn't we multiply? Why didn't we have this? This is what I'm asking. Let me. Why didn't we have that?
Mr. Go ahead.
Daniel, we're talking. Let me hear from Matthew. Thank you very much, Daniel. Yes, we can go ahead and do question 5, Daniel, in the meantime.
Miss, she can go ahead so me can learn too.
Of course, we're learning together, but she's the one who, all being fair, she's the one who highlighted the answer. So I want to ensure that everybody is on the same page, not just Daniel. You think it's Daniel alone I want one from? No, sir. Daniel is just one out of the many. I haven't heard from Shante. Shante, you want it to help Matthew? Seem like Shante fell off. Oh my. I hope she gets back on soon. Javia, do you want to assist Matthew, please?
No, miss.
Why? No, miss? Oh my
Miss,
gosh, something happened today.
do it because that's necessary, so we do it. I don't know the reason behind that, but I just want to say thank you for that, because of that. Thank you.
All right, so did sir say that you should put the 2x minus 3 in front of the cosine?
No,
What did he say?
the 2 alone.
Why the 2 alone? Why
Because
I didn't find the derivative of 3 and put 3 there? Can 3 go into the front as a coefficient? What are we differentiating?
Differentiation of a constant.
0, yes.
But Aniki. All right. Okay, no problem. Good. Matthew, did you get that? So we're differentiating within the bracket here. We're differentiating here, right? And we're saying that when you're differentiating the terms, when you're differentiating the constant, it always equals, what would he say? What did he say? It ceases to exist, right? So when you're differentiating 2x, which is raised to the power of 1, you get 2. That's how you end up with 2 cosine, right? And you leave the term here. We cannot trouble the term here, right? Right. We cannot trouble the term here. So let's see what was the result. What did you get for question 5? So I think all of us now are on the same page. So first, we are differentiating sign, right? We got the solution, we change it to cos, right? And then we have to differentiate within the bracket here. And we are applying what? The chain rule, okay? So let's try question 5. What was the solution did we get for question 5? And we're closing off in the next 5 minutes.
It's positive 15.
Is who
Positive
talking?
15 sine 5x.
Matthew?
Yes.
No, sir. All right, Matthew, I'll take that one. Anyone disagrees with Matthew?
No, miss, I agree.
You agree. All right. Shante, welcome back. Is it that you fell off?
Yes, miss.
All right. So we have just discussed question 4. We are at question 5. Matthew gave the response to be 15 sine 5x. Do you agree?
Yes, miss.
Why do you agree, Shante? You sure he's right?
Yes, miss.
Okay. All right. Last one. Find we're evaluating dy over dx minus 4 sine 3 over 2x. This one get you thinking, right? Just a little bit. I've already told
Yes,
Sir I'm
miss.
preparing now a worksheet for you, a form to get the some additional practice. So, sir, you can stand by. We're doing the last question.
Finish, miss.
Thank you, Tanil. I thought Matthew was going for the challenge. Or John Mark. John Mark,
Yes, miss.
what is the solution, John Mark?
3 cosine 3 over 2x. That's what I got.
3 cosine
3 over
3 over
2x.
3 over
Yeah.
2x. Okay. Anyone get anything different? Thank you,
Yes,
John
miss.
Mark. Hold it, Tanil, hold it. Anyone else?
Miss 36 cos 3 over 2x.
Did you just say 36?
Yes, miss.
All right, I'm writing it down. 36 what?
Cos
36 cos
3 over 2x.
3 over 2x. Anyone else?
Negative 36.
Negative 36. Okay. Okay, Aniki. Anyone else? Thank you.
Miss, I got negative 6 cos times 3 over 2x.
Okay. Thank you, Shante.
Miss is wrong something. It's negative 6. Negative 6 cos. Negative 6 cos 3 over 2x.
Okay, thank you. So I get in 2 persons saying that option. Kadil, what was your solution?
Oh, miss, negative 6 sine 3 over 2x.
Negative 6. You said sine
Sorry,
3 over.
cosine.
Okay.
3
Okay.
over 2x.
All right. So this is 3 persons saying that. Anyone else? Thank you, Tanil. Chanel. Chanel. What about is it Miss Fox? Can you share, either of you share your response? I'm going down the line. Miss Davidson. Let me see if there is any response in the chat. Okay. Okay,
Miss
Shania.
question.
Go ahead.
Miss at number 6, is that minus 4 sine? Is that
Yes,
minus
it
4
is.
sine 3 over 2x or 3 over 2x?
It's
Or
minus 4.
is the fraction and the x separated?
No.
Okay.
Okay, let me hear the working out, please. Who is let me type, and sir can get ready to come on. Let me type. What is the first step? So we know we are writing back the dy over dx, right? And we're saying it being to be equal to what? What's the first step? Let's see if I can put it here. What's the first step?
To remove the sine and replace it with cosine.
Okay. Let me, not looking at the response now, so you guide me. Right, so this is 3 over 2 x. What's the next step?
Differentiate the 3 over 2x and times it by -4.
Differentiate. So we are having -4 times 3 over 2 and cos, writing what you have just said, cos 3 over 2x. That is it?
Yes, yes.
All right. So let's go. Are we missing something?
Miss, you're going to multiply the -4 by the 3 over 2.
Okay, and we're gonna get -12 over 2, which gives you
-6.
-6 cos 3 over 2x. That is a solution.
Yes, miss.
Are we all clear?
Yes, miss.
All right. Anyone not seeing? Where did I get the, repeat the question?
It's the 6.
Okay, so we have -4 times 3 will give you 12, and we're dividing by 2. See it here? So we're saying, are we clear? We're multiplying the fraction. So we will have -4 times 3, right? And all of this will be now over 2. So that will be 12 over 2. Okay, minus -12 over 2, right? So are we all clear?
Yes, miss.
All right. And remember, guys, you need, now is the time for you to be coming to class with your questions, your practice questions. So any question that you're practicing and have any hiccup, I'm telling you, please bombard sir with it. This is without notice. As I said, don't lay your hands on a man suddenly. Yes, go ahead, Tati. Davidson. Or are you just agreeing with me? Davidson? Okay, probably she was just agreeing with me. Yes, agree. I agree. So do your practice questions. So in your practice, when you come up on a difficult or challenging one, we're going to come to class and say, listen, sir, we're going to take 2 minutes. I have attempted this question, and you pose it to the class, and I've been challenged with it, or I've found it intriguing enough to share with the class, because this wasn't that straightforward. But yes, I got the answer, but I think it's a good approach to share with the class. Okay, so sir.
Yes, miss, I'm here.
Okay.
All right. My story continues because after that, Sorry. There is a, what is it? What is it? Anyhow, a session for the evening students. And I'm sure if my supervisors look in the participants list and don't see my name populated, they're going to say, oh, and you weren't there. I think they will forget that I have a class. But never mind, I am here. All right, so I have been listening. I have a few comments. Aniki, unmute for me, please.
Yes, sir.
So why did you give the answer in the first part of the lesson that Miss did, and then you said, well, Miss, maybe I'm wrong here, I doubt in myself. Why did that?
How many things are wrong?
No, you have to say at this stage, Nikki, we need to develop some levels of confidence. That's what we're trying to do, Mrs. Henningham and myself. And I know she's proud of you. I am proud of you. So I want when you speak with confidence. Even if it's a teacher teaching something, I believe that you are right, say to the teacher, sir, I think I'm right. Chances are I could be wrong. Let me look back at it. And if I am correct, I said, okay, tell me why you think that you are correct, Nikki. And then I can use that opportunity to undo your misconception. But I want you to develop that level of confidence. Who was it? Was it Davison? Anyhow, somebody was asked the question, why is this so? Miss, I don't know. Sir, must just be like that. All right? Now, remember, what I want you to do is, I'm happy that you are following what it is that I'm saying, because I'm leading you, in the right direction. But my aim is to develop independent thinkers. I don't know how CXC will set their questions, and I want you to be able to understand the nuances of what it is that we're doing inside out. You see, when Miss put the question and think 3x to the 5th, 15x to the 4th, Miss. Yeah, because I want you to be able to see what is happening, understand what is happening. So whether or not, John Mark, you just came in to class and you log on and a differentiation question is on it, you're supposed to be able to answer. What's the point I'm making? You're sleeping and somebody call you and ask you a question. How you differentiate that? 2x squared plus 5. And you don't make them sleep. I want you to be able to have the information at your fingertips. You guys are doing well. But time is against us. This is April. Jesus. This is April. April. Tomorrow, next month is what?
Integrated math exam.
Okay, thank you, please. So a while ago I said that and I felt something in my stomach move. Tomorrow, next month is your integrated math exam. I don't hear anything from CXC. I don't know what CXC is doing, but tomorrow, next month, today, tonight, next month, I'm sure I'm in class with you going through past papers and say, okay, let us run it. Come, what is happening? John Mark, not answering. Tanil. I am going to be doing that come next month this time to bless you off for next month tomorrow. We have a month. All right. I sense that there are some of you who are, oh Lord of Father, I cannot believe that I'm logged onto this thing for so long, but yet still I didn't log into this other device that I'm sharing from. What is wrong with Mr. Shani? What I want you all to do at this point in time, you're supposed to be firing. You're telling you firing, your others are firing, Nick is firing, but guess what? Nick is out in herself. Matthew, me and you will have it out, You and I, you're not going to follow because, you have the framework, but I don't know if those classes that you miss are the reason for you not to have that sort of confidence, because I hear the reservation in how it is that you're answering this stuff, but I know you can do it. And depending on you, so please do all that you can. Oh, hold on, sorry. All right. Come, I'm taking you to a quick exercise on Editor Soft. A quick exercise on Editor Soft. Aniki, if f of x is equal to 4x minus 3, find f dash of x using the limit definition of the derivative. Come, differentiate this one, please, Aniki. Answer. Quick. What is it? Differentiate. Find f dash of x only, please. Come, time is going quickly.
4x minus 3.
When you differentiate 4x minus 3, what is your answer? What?
4x minus 3.
Okay, it's a 4x minus 3. All right, and I'm going to click done. And what that says? What it says?
Incorrect, sir.
Right, so when I ask you to differentiate 4x minus 3, what do you get, Aniki? Watch this. Shante, what do I get?
4, sir.
4, all right. Aniki, I'm putting 4. Is that correct?
Yes, sir.
All right. Now, let me not even look at that solution. Aniki, 6x minus 7. When what?
6.
6? Okay, you catch it now. All right. Javier.
Me a while ago.
No, because I'm doing a quick time. No, quick time. I'm rushing everybody. Quick time. Javier. Answer. All right, correct. John Mark, answer.
6, sir.
Good. Kasana, answer. Kasana Green, answer. I'm not hearing you. What you said? Okay, 3, heard that. Good. Henry, answer.
9, sir.
Good job. Matthew, answer.
2, sir.
Good job. Come on, 2. All right, good job. Hall, answer. Good. Whitfield, answer. Chanel, answer. You are sleeping. Foxy, answer.
I'm 6.
Tati D, very good. Tati D, answer. Come on now, guys. Come now. Tatiana Davison, answer. Tatiana Green, answer. Okay, thank you. Carrie, answer.
Thank you.
All right, thank you, sir. All right. That is 15.1. Oh, come on. You know, believe that's so easy, Wemby? You better believe. That's the first stage of the differentiation. I mean, if I don't reach product cool, you know. So best believe that it's going to be so easy. All right, forgive me. All right. All right. as I said before, I'm just into this meeting listening because they have a tendency to call me Mr. Shand. So forgive me. I'm fully committed to you though, so don't feel that I'm not right here. Coming, starting again. Nikki, if f of x is equal to 9x squared, differentiate for me, please. Answer. Okay, thank you. New share. Answer now, please.
Yeah, it's not showing.
It's not showing?
Yes, sir.
No, sir.
Strange. New share.
Sir, I think there's something you use edit the on screen.
Okay. Are you seeing it now?
No, sir.
Yes, sir.
Yes, sir. Seen it now.
Are you seeing the other? Are you seeing this page too?
Yes, sir.
All right, quickly. I can't go through the participant list. Quickly, what's the differentiation of that?
18x.
How much? 18x.
18x.
All right, good job. Answer.
20x.
20x.
Good job. Come on, Tyreek, I want to hear from you too. Come on, answer.
22x.
All right, great. Answer.
12x.
All right, good. Answer.
30x.
All right, I'm gonna catch that. All right. Moving. I keep doing that. All right, I need to do a new share on this page. Are you seeing the page?
Yes, sir.
Differentiate for me, please, quickly.
18x plus 4.
18x plus 4, correct. Everybody say that? Who don't see the 18x plus 4? Very nice, very nice. Come next.
6x plus 9.
Very good. Next.
14x plus 3.
Oh, I left out the plus sign. All right, good. And next, quickly.
6x plus 8.
You hold on 1 minute, please. Tatiana Davison?
Yes, sir.
Are you participating?
Sir, I was not here.
Oh, you're here. Okay, you're back now. Okay, great. Because yeah, man, I want to hear from you. Nathaniel, are you participating?
Yes, sir.
Okay, Chanel, are you okay?
Not really, sir.
Okay, tell me where you now follow. What is the problem?
In kind of coming late to know what really happened.
Me know. That's why I call upon you now. Answer me. All right. So them tell me say 6x plus 8 is the answer for this one. And I'm differentiating the function. If f of x is equal to this polynomial here, I'm supposed to find f dash of x. F dash of x is the first derivative of f with respect to x. What I'm doing, as Mrs. Henningham did just now, I'm using my power to multiply by the coefficient and reduce the power by 1. 2 times 3 is 6. So I'm going to get 6x. I reduce this by 1, so it's going to be 6x to the first power. 6x, done. X is raised to the first power. 1 times 8 is 8. I reduce this by 1. 1 minus 1 is 0. Anything raised to the power of 0 is 1. Differential of 8x, 8. Differential of a constant is always equal to 0. I know I said that fast enough. Next month, this time, all right, good. You kind of get it. All right. No, don't unmute, you know. I mean, don't mute, you know. Tell me the answer for that one.
Sir, 14x plus the 9.
All right, very good.
for her presentation. I think based on
Hold
the
on.
engagement, we can see how enriching and inspirational it was for all of us. And she told me she was going to be brief, but it was worth it. Even she has not changed. Talk, and I guess that's why she said herself on TV these days. But it was uplifting to have her, and we know we can always call upon her when needed, and that's one thing about her. She's always so thank you, Tammy, and I've talked to you later. I think some of our we get some questions in the chat, so probably
All
we
right.
want to turn over now.
All right, very good. I'm going to do, let me just see something. All right, so those are repeating questions. All right. Oh, why do I keep doing this?
Sir, I don't hear you asking the males. Protect the males.
Okay, all right, Miss. Okay, I hear you. All right, no, I don't count that one just yet because.
All right, so for students, 5 courses in a semester is not norm.
All right. Okay. I think this is it for now. Terry, John Mark, Matthew. Okay, no. Okay. This one is new. All right, Terry, this one is yours. Differential.
Just a big black box.
Oh, I am telling, and honestly, all right. Tell me if you've seen it now.
Yes, sir.
All right, Terry, your turn.
So believe it or not,
10x plus 3.
Thank you, sir. Matthew, your turn.
X plus 2.
Thank you, sir. John Mark, your turn.
12x plus 5.
All right. Mrs. Cunningham, are you okay now, Mrs. Cunningham? I
feel a little better, yes.
Oh, bless the Lord. All right. Okay, guys. I did something very quickly a while ago because I wanted you to feel connected. Where I went just now was your Edicosoft. I logged on Edicosoft just now while Miss was doing this stuff, and I recognize that some of you don't log on for a while now. To whom much is given, of him or her, much is expected. And if it is that you don't put in the stuff into it, guys, it's not gonna work. And I really want it to work. All right. You know, one of the things that I'm happy about, I'm gonna tell you straight up. So I used to like math when I was going to school. Oh my goodness. I really hope you can believe my story. Oh Lord, forgive me. So when I was in little school, I used to, oh Lord, I feel so bad about this, but oh Lord, forgive me again, Jesus. I used to, when my friends don't do their homework and the teachers going to beat them after lunchtime for their math work, I used to, let me use a nice word. I used to barter. So they had to give me one of those 50 cents coin. You don't know what those 50 cents coin look like. That's octagon or something. So I used to just run through like 20 questions and, you know, just collect some 50 cents coins, you know. And sometimes when I'm finished, I'm having like $5. No, back then, $5 was enough money. You understand? When I say plenty, enough money. I could go to KFC every evening and buy me my, matter of fact, you see where Island Grill is in Twin Gates Shopping Center along Constant Spring Road, right beside the big mega store in Quartz. KFC was right there. So many years ago. If you don't believe me, ask your parents, right? I used to find myself there every evening to buy me my one-piece chicken and biscuit to the point
Sorry,
where
you're not that old.
Okay, all right. All right, bless the Lord. I received that in
Sorry,
Jesus' name.
you can't be that old.
I receive that in Jesus' name. I receive it in Jesus' name. Thank you, Tantan. You know, I really appreciate that. But no, on a serious note, I used to love math. And you know, one of the things that I used to just sit down and just, you know, my parents used to say to me, there are other subjects to be, you know, like English and social studies, and then something there. When I'm bored, I just do the math. What's the point I'm making? You have to be able to be enthused about your schoolwork. Something has to get you excited. It's just like, well, I was going to wake up a morning time and go check Facebook and Instagram and me hear people talk about this blast and loop and pink wall and them something there that I don't even know how to get onto, and Twitter and them something there I don't know how to. The only thing I can get onto, guys, is TikTok, right? And my main purpose in getting onto TikTok is, you know, say anything that happen, people have to text picture and video and post on TikTok, and that's how I stay alert. All right. But I'm gonna say to you, I really want you to get that sort of energy like you have for social media for your book work at this point in time. We have exactly a month from today. Exactly a month from today. It is going to happen. I promise you, it is going to happen. Tonight, my aim is to look at the other rules of differentiation so that I can go through another round of exercise like I just did. There's one whole unit that I don't start it, and I'm about halfway through calculus. It means that I need to rush through calculus by next week. This time I'm supposed to be finishing off calculus so that I can use the other 2 weeks to do statistics, right? So I'm going to just be frank with you. There are some areas in statistics that I know must come. I'm going to start with those areas first. Measures of central tendencies must come. Mean, mode, median must come. Variance and standard deviation must come. I'm going to go through that. Regression and linear must come. I'm going to go through that. Because at this point in time, you know, we have lost about 2 months. We normally start in September, like not 2 months. We have lost about a month. We normally start in September. No, it's about 2 months because we normally start school early September. The second year students normally come back early September because you would get results early. I mean, we never started until the 25th of October. So we started about 2 months later. So those 2 months would have done me very well, very, very well. But anyhow, let us go. So the last time around, we looked at differentiating or chain. Let me just share this document with you. Differentiating or chain. Share screen. Differentiating or chain. And I did say to you that there are some other things now that include our product rule and the like. So, oh Lord, forgive me. Did I do that? All right. Did I prove this for you last class? The power rule?
Yes, sir.
Yes, sir.
Yes, bless the Lord. And I did, and I'm okay, yes. And I went through the exponential function that the differentiation of e to the x is e to the x. Everybody remember that?
Yes, sir.
And I didn't do the quotient one because I have not yet taught you the quotient rule. Okay, great. The logarithmic function. Let us just run through the logarithmic function so that I can go through the rules now of differentiation. I don't understand why I'm not seeing the power rule. I mean, the product rule, okay, it's right there. So let me just go to the logarithmic function, which is really not too long. I won't go through this part down here. I just want to do these 3 examples just to show you something. Then I'm going to jump down to differentiating products and quotient, which is my 2.7, and then I can come back up here and do this. You may be saying, sir, why are you moving up and down in your document the way I'm moving up and down? I'm not. I am very structured. But you recognize these are past papers, and I put the past paper here because it involves logarithm, Ln, and the exponential function. And that's where I'm at just now, the logarithmic exponential function. Right here, exponential and logarithmic functions. I have not yet done with you the product and quotient rules. So as soon as I do those, I will come back. I could put those questions at the end of the document, but I just want to keep my content together. So that's why it looks as if I'm jumping up and down. All right? Normally what we'll do in the normal face-to-face, I'll teach you the rules, and then we'll just go with the mixed questions. All right? So please appreciate the madness that I'll have to do now in order to get the content out of the way. All right, so let's just look at some logarithmic functions. So we need to differentiate the following. No, it's the differential of ln x, which is a natural logarithm. The differential of ln x is always going to be 1 over x. The differential of ln x is going to be 1 over x. Ln x, x can be any function. X can be x squared plus 1, 2x minus 1, 4x plus 3p, whatever the function is. Once I'm differentiating the natural logarithm, the differential of the natural logarithm is going to be 1 over the function. But remember now, I will have to differentiate the function itself. So the differential of x, so the differential of ln x is 1 over x. The differential of ln x is going to be 1 over x every single time. The differential of ln x is 1 over x. All right? Now, if I say to you, what is the differential of, let me look at my second one. If I say to you, what is the differential of ln 2x? It is going to be 1 over 2x. But I have to now differentiate the 2x, as I did with the trigonometric functions last week. All right? As I did with the trigonometric functions last week. And then I'm going to multiply that by my 1 over 2x. So I'm going to get 2 over 2x, which is the same thing as 1 over x. Hold on, sir. You're saying to me that the differential of ln x and ln 2x is the same 1 over x? Yes, I am. The differential of ln x, the natural logarithm, is going to be 1 over x, 1 over the function, times the differential of the function. So therefore, the differential of ln 2x is going to be 1 over 2x, times the differential of 2x, which is 2. So I'm going to have 2 over 2x, which is the same thing as 1 over x. The differential of ln x plus 1 is going to be 1 over x plus 1. So once you get the natural logarithm, ln, it's going to be 1 over that function, but differentiate the function and then multiply by the 1 over the function. So the differential of x plus 1 is going to be 1. And 1 is a multiplicative identity. So when I multiply 1 by 1 over x plus 1, it is going to remain 1 over x plus 1. Tell me if this is not easy. Talk to me.
Yes, sir.
Somewhat.
Okay. Tell what you mean by somewhat.
Sir, somewhat. So when you reach into the topic, then I think I'll get it better.
Okay. When I differentiate ln 5x, what do I get?
1 over x.
Do you agree with 1 over x, guys?
Yes, sir.
Yes, sir.
Yes, sir.
Why? Tell me why you agree with 1 over x.
Because of the differentiation.
Sir, because when I differentiate ln x, you always get 1 over x.
Yeah, but I have 1 over 5x.
That would be 1 over 5x times 5.
Very good. And I'll get the 1 over x. I don't want, not because I had 1 over x here, it means that its answer would have been 1 over x. I want you to tell me 1 over 5x times 5, 1 over x. That's all that there is to it. No. I want us to have a relationship, guys. That when I tell you something, I want you to believe me. I want you to believe me. There is nothing more in the differential of the logarithmic function than what it is that I'm showing you. What may become a little tricky is that the function, the logarithmic function, may have a product or it may have a quotient. But I don't show you the quotient rule yet, and I don't show you the product rule yet. But just remember, The differential of the exponential function is the exponential function. What do you mean, sir? The differential of e to the x is e to the x. The differential of e to the x is e to the x times the differential of the power. So e to the x or e to the 1x is going to be e to the x, and when I differentiate 1x, I'm going to get 1. The differential of ln x is 1 over x every single time. If you can start with the base, you are good to go. The differential of e to the x is e to the x. The differential of ln x is 1 over x times the differential of the function. The differential of e to the x is e to the x times the differential of the function. The differential of ln x is 1 over x times the differential of the function. Let's go. This example I can't do just yet because it involves a quotient. So just allow me now to just jump to my other rules.
So I've been getting this ruling and here is ruling that we have to come over.
The product rule. The next something, you know, product rule. I want you to sing my song. This is the first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. All right. I want to watch me.
Year one evening.
Sorry, they just spoke about something a while ago that I thought my name was going to be called. Let's go. So y is equal to 2x squared times 5x minus 3. 2x squared times 5x minus 3.
I'm still having a bit of challenge there because
Hold on.
we were told that our course will be an online.
All right. So this is going to be my first. This is going to be my second. Sir, do I have to call the first one first? Could I not call the second one first? Yes, you can. But for the purpose of just doing this and just getting it out of the way, we're going to call the first one first. If you want to call the second one first, it's up to you. But let us do the first one first. So the product rule, as it says, product, it means that you're multiplying. Product, it means that you're multiplying. All right? Watch me. Don't blink. The first times the differentiation of the second. When I differentiate the second, the differential of a constant negative 3 is equal to 0. The differential of 5x is equal to 5. Do you understand why I was doing the exercise I was doing earlier? This is the reason. The differential of a constant is always equal to 0. Every single time, barring none. The differential of a constant is always equal to 0. Barring none of the times. All right? Are you hearing me?
Yes, sir.
Yes, sir.
All right, good. So now, every time I call the first, I write it back. Every time I call the second, I write it back. So watch me. The first times the differential of the second plus the second times the differential of the first. The first, I write it here, times the differentiation of the second. When I differentiate the second, I put it here. Plus the second, I write back 5x minus 3 right here, times the differentiation of the first, which is going to be 4x. At this point in time, students, you are supposed to be able to differentiate by inspection. So that's why I was pretty encouraged when Miss placed a question on the board. You know, on the board, you know what I mean. And Tantan was able to respond. Nikki was able to respond. Oh, I'm coming back to something. Nick was able to respond. And that's what I like because you have to be able now to look at stuff to differentiate it pretty quickly. I don't want to say anybody at this stage, okay, this times this, I need to subtract 1 from the power. No. That's how when you learn differentiation. No, you're supposed to differentiate by inspection. So it's first times the differentiation of the second plus the second times the differentiation of the first. Differentiation ends right here. What it is that we're going to be doing next? 5 times 2x squared is 10x squared. 4x times 5x is 20x squared. 4x times negative 3 is negative 12x. Then I'm going to merge my like terms. 10x squared plus 20x is 30x squared. Then surrender the minus squared from it. 12x is a different term from x squared. So the negative 12x is a term by itself, so I'll leave it here. If I want to go further, I can look to see what is common here. That is common here, and I answer the 6x. What will be left? 5x minus 2. This is how we differentiate the product.
Sir, can you do the line in blue again?
The first times the differential of the second. And that I'm differentiating the second. When I differentiate the second, I'm going to get 5. Plus the second, I put in plus, and then I'm writing the second. Times the differential of the first. I want to need to differentiate the first. When I differentiate the first, 2x squared, I'm going to get 4x.
Sir, the line in black.
5 times 2x squared, 10x, plus 4x times 5x is 20x squared. 4x times negative 3, negative 12x.
Okay, thank you, sir.
No problem. 10x squared plus 20x squared are similar terms, and I can group them together, which will give me 30x squared. My negative 12x is a standalone, so I put it back. When I factorize, I can put it in this factorized form. Look at that example 1, and I want you to make an attempt of example 2 for me, please. On your mark, get set, go. I want everybody to participate in this exercise, please. All right, I'm with you, but oh, come on. I'm with you, but it's a good thing that I just took the tablet because some students are actually asking me questions in the chat. So I'm with you. Let me know when you're finished, please.
Finish, sir.
Finish?
Yes, sir.
Mm. What's it called for the answer, by the way?
Four x open bracket 3x minus 4 close bracket.
All right. Maybe this is a good time for me to talk about something now. So when Miss was talking about the 3 over x, remember indices? Remember logarithms?
Yes,
When
sir.
right. So when we have 1 over a to the m is equals to a to the negative m. So we can't forget indices, because indices is going to be very important to us. I remember what Tanya was saying that, erroneously when she said that she's going to carry the, well, she never said something correct at first and then corrected herself thereafter. Remember, what I had last week was 1 over x to the 7, and then it became x to the negative 7. If you have 3 over x, the 3 is already in the numerator. So that is not going to change. There's going to be 3x to the minus 1. You have to go back and relate it to your indices. You have to relate it back to your indices. There's no way you can divorce your indices and logarithms at such a time as this. Right? You're going to need those laws of indices. So I heard an answer a while ago that I'm not in agreement with.
Say I wrote out the question.
Oh, you wrote up the question wrong. Okay, fair enough. Did anybody get the answer that I got on board?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Is there anybody else who has a difficulty with this or wants me to explain something? Go ahead.
So I do the second, I get the second part of it.
No problem. So it is the first times the differentiation of the second plus the second times the differentiation of the first. Watch me. This times the differentiation of this, then plus this times the differentiation of this. So I go here, differentiate here, I write back this, then differentiate this. Start here, differentiate this, plus this, differentiate this. Start here, differentiate this, plus this, differentiate this. The first times the derivative of the second, plus the second times the derivative of the first. First times dy by dx of this, plus this times dy by dx of this. Right? So the first, I write it here, times the differentiation of the second. Differentiate a constant, I get 0. Differentiate x cubed, I'm going to get 3x squared. Plus the second, x cubed minus 3, times the differentiation of the first, 12x squared, right here. Differentiation ends in blue. I'm removing my parentheses here now, so I'm going to say 4x cubed times 3x squared. 4 times 3 is 12. Indices again. When I'm multiplying and the bases are the same, I'm adding my powers. See here, see the recall here? A to the m times a to the n is equal to a to the m plus n. Anybody remember this at all that I did with you?
Yes, sir.
So indices says, once I'm multiplying and the bases are the same, I add my power. So x to the third power times x to the second power. 3 plus 3 is 5 is x to the fifth power. X cubed times 12x squares is going to be 12x to the fifth. Same difference. Bases are the same. X cubed, x and x cubed, x squared. I'm multiplying. I'm going to add. And then this is negative 3 times 12x squares is going to be negative 36x squares. Again, these two terms are the same in terms of x to the fifth and x to the fifth. I can combine them. 12x to the fifth plus 12x to the fifth is going to be 24x to the fifth. My negative 36 is a standalone, so I'm going to write it back as negative 36x squared. Again, I can go ahead and factorize what is common in here, that is common here. Hello? Hello?
12.
Yeah, no. Are you hearing me?
See a screen.
I know, because I just got disconnected. That's why I was saying hello, hello, but you weren't answering me.
Sir,
Yes, honey.
sir, I have to do the last step. What I have to do?
It depends. They could be asking you. They could be asking you.
Okay, sir.
Mm-hmm. All right. Hold on 1 minute, please. There's a student in the meeting, the principal, that has asked me a question. Look at that one for me, please. In the meantime, let me just respond because they might talk. So when them email the lecturers are not responding. I hope that's not me, because my fever hit them get so tired for
Sir, I'm not
responding
seeing the other
to many
question.
emails.
Scroll down, sir.
Okay,
Scroll down.
okay, my bad. I apologize. Yeah, all right. My internet, it says that my internet is unstable, so let's hope it don't. Okay, are you seeing all the question now?
Yes, sir.
Yes, sir.
All right, try that one for me, please. Very well, guys. Got it. Oh, no, my internet is unstable.
Then as an administration, you would have to try to put things in place to accommodate that, right? So these are things that online where we don't start have because of the fact that we're having consultation and recommendation that
I'm supposed to be able to touch a student's name and comes up.
online and right? Or fully online.
Everybody finish?
Yes, sir.
Yes, sir.
What?
Yes, sir.
What's the answer?
6x plus 2x squared minus 2.
Yeah, 2x squared plus x minus 1.
I hear the 6x squared now. But I also heard that 2x squared minus 2.
Yes,
Did you
sir.
say 2x?
I did the factorization part. 2 times 3x squared plus x minus 1.
Fair enough. But I heard a male said 6x squared plus 2x squared minus 2. John,
Oh,
was that
sir.
you?
Yes, sir. My fault.
Okay,
When I
but
multiply the 2x by the 2x, I didn't put the square. That's the
okay.
issue.
Okay. So you see the error. Is there anybody in the class that is not getting what it is that I'm getting here? No, Shan, talk to teacher. Mm-hmm.
So 2x in the blue line is not 2x squared to be.
Say it again.
So in the blue line, the first line.
Mm-hmm.
So it's not 2x squared that's supposed to be.
The first, which is this, times the differentiation of the second. The differentiation of the second, I'm going to get 2x plus the second, which is going to be plus x squared minus 1, which is this, times the differentiation of the first, which is 2.
Mr. Sean?
Yes, I don't care about the square. Oh.
Mr.
And then,
I thought you put back the square and the x and you do that.
Who is calling me? Shan?
No, sir.
Oh, a long time I hear from you in Buckley. What on?
Sir, I don't like that. Don't call me sir. Don't call me sir.
I saw your father name you, and I saw me I call you Buckley.
Sir, call me Natty B.
All right, go on, honey bunches.
Sir, I don't understand not know what I go on.
Oh, Papa Jesus, take the cross, Jesus. Natty B.
Sir, let me tell you why I don't understand, sir. Cause remember say you see me from Friday, you know, sir.
Mm-hmm.
Sir, I think that's why. This look new.
So you weren't in class on Friday?
So yes, we did it Friday. But I remember if we did it Friday, but I know I never did it Monday for sure.
Oh, that's a problem. That's a problem.
So I did a call, but you never answered before.
Oh no. All right. You need to link me. Go on to the stuff. Go on to the stuff and when I say go on to the stuff, go on, try pay attention, and then you and I will have to link. Are you coming tomorrow?
Sir, I don't know nothing about tomorrow. Sir, remember you see me from weeks if I did tell you Monday about tomorrow, I wouldn't know.
All right. So I'm meeting my business calculus students tomorrow again, and I will share the link with you.
Yes, sir.
We are going to be doing more of these questions, differentiation. If I am going to be doing something that is not on your syllabus, I will prepare some questions and send to you in your WhatsApp group so you can sit in your WhatsApp and do it, and then we have conversation on it. But I'm going to invite you again to come out to the class.
Sir, yes, sir. Me I go come.
All right, good. Tantan, I need to see you. Tantan, don't play with me, you know.
Sir,
I need to see you
tomorrow.
Thank you, please. Thank you. Matthew, how you stay?
Sure, I'm good.
Nice. You come class tomorrow?
Sir, online or face to face?
Face to face.
Can't come.
Why?
Our next class early in the morning.
Oh, okay. I know it's supposed to be online, you know, but I mean, I was wondering why it is that you asked me if it's online or face to face. It's going to be online. What time is supposed to meet you with you tomorrow?
11:45 to 1 o'clock. I'm going to go pure maths after that, so I know
you can't make it. Never mind. You can't make it. Never mind. Yes, please.
Sorry, can
Go
I
ahead.
explain how you get the first line, please?
Yeah, man, I'm going to go through again.
Sir.
Yes, Papa.
So what time is the class?
The question.
8 o'clock. Say it again, Matthew.
As we can send the work, the question, and we're going to do tomorrow to me.
Yeah, man, I'm going to put it in a WhatsApp group so you can just extract it from there.
Thanks.
No problem. I was not checking the chat from this meeting from before. And I'm recognizing that there were some questions that were directed to me. Let me just give me half a second, please. I want you to look back at what it is that we're doing because we're getting this thing. The first times the derivative of the second plus the second times the derivative of the first. The first times the derivative of the second plus the second times the derivative of the first. Goodness. How do you send? I can't send voice. I can send voice note. Hey, Zoom supposed to be able to send voice note. By the way, let me ask you: can you send voice note in Zoom in the Zoom chat? No, yes or no?
No, sir.
No, sir.
No man. Zoom me for do something no to that man. All right. All right. All right. All right. Come, sir, principal. You said that you reached the last point, and you tell us come fully over here. All right, let's go. Let's go for example 3. Numero tres. The first times the derivative of the second plus the second times the derivative of the first. The first times the derivative of the second plus the second times the derivative of the first. Come, Natty B, ready? When I call the first, I am going to write it. The first, 2x plus 1, I write it, 2x plus 1. Times the derivative of the second. When I differentiate the second, remember the differential of a constant is equal to 0 every single time. Yesterday, today, and tomorrow. And the days after that. And when I differentiate the my x squared, I'm going to get 2x, which is a 2x right here. So this is the first times the derivative of the second. Watch me now. Plus the second. So I'm going to plus the second here. Plus this, the second. See it right here? So now times the derivative of the first. The derivative of a constant is equal to 0. So when I differentiate 2x, I'm going to get 2. My differentiation ends right here. All I'm going to be doing now is fixer-upper. Fixer-upper. 2x times 2x is 4x squared. 2x times 1 is 2x. Finish with that. Start with this. 2 times x squared is 2x squared. 2 times negative 1 is negative 2. I need to fix up this in black. 4x squared plus 2x squared is going to give me 6x squared. My 2x is a standalone, so I put it back. So is my negative 2, I put it back. What is common here? That is common here. That is common here. 2, sir. And I'm factoring out the 2. Sir, we have to write this last line. Chances are maybe not. I think that was Shante, Xavier, one of them asked me. Maybe not, right? But this would be my differentiation. All right? Any questions regarding that so far? Remember, tonight is for me to teach you the quotient rule and the product rule. And I'm seeing this is 7:34. So tell me now, are you understanding the product rule so far? It is the first times the differential of the second plus the second times the differential of the first.
Sir,
Yes,
can you
I
please go
understand.
over, can you go over, you got the 2x right there in between the plus and the second derivative?
Which one now? This one right here, this line?
Yes, sir.
All right, watch me again, guys. I'm going over the question. Watch me again. You will know what a product looks like. A product is something times something. A product is something times something. The product is something times something. The first times the derivative of the second plus the second times the derivative of the first. The first times the derivative of the second plus the second times the derivative of the first. The first times the differentiation of the second plus the second times the differentiation of the first. Okay, all right, good. I'm all ears now. Meeting just ended. The first, anytime I call the first, I write it back. Anytime I call the second, I write it back. The first, I write it. Times the differentiation of the second. When I differentiate the second, I'm going to get 2x. Differentiation of x squared is 2x. Differentiation of a constant is 0. Plus the second, I write it back. Times the differentiation of the first, I'm going to get 2. Then I'm going to distribute over the parentheses. 2x times 2x is 4x squared. 2x times 1 is 2x. And if I want, I could have said 2x times 2x is 4x squared. And then 1 times 2x is 2x. Same difference. It don't matter which one I use first. X squared times 2 is 2x squared. And negative 1 times 2 is negative 2. I'm grouping my like terms. And I recognize that 4x squared is similar to 2x squared. So I'm adding 4x squared to 2x squared to give me 6x squared. My 2x is a standalone, very lonely, I write it back. So is my positive 2, I write it back. Hitchman, are you okay now?
Yes, sir.
All right. Run that for me, please. I just made up that one. Run it for me, please. The first times the derivative of the second plus the second times the derivative of the first. Oh, come on. I still see my screen?
No, sir.
No, sir.
Yeah, my system is. Oh, my gosh. I don't know why it's behaving like this tonight. I come in, it's loading and loading and loading and loading. Mm. Is it still saying that I'm trying to share my screen?
Yes,
So it's just loading.
Oh, come on. Did you get the question before?
Yes, sir.
Yes,
All right,
sir.
please. All right, one work from here.
Sir, finish.
We finished? Lord Jesus, I mean, I started yet. All right. Okay, Satan. You can just stop now. I'm not in any playing mood with you. All right. I need to have my class. So go find somebody who is your calm. Don't play with me. You know, God has a sense of humor, you know, and while the system is, I hope it's not shutting down. I never normally like conducting my class from my cell phone. Never normally like conduct my class from my cell phone because my phone rings constantly. Somebody said, "Sir, I was calling you." My phone rings constantly, and I don't know why tonight I decided I'm gonna do. Well, part of the reason is that I was on the outside doing some work, and I said that I'm gonna connect my class on my cell phone. And then I said to myself a while ago earlier, and I said, "But life funny is one time my cell phone rang, and it was when Mrs. Sellingham was teaching, and it don't ring since." I said, "For God, you're good man." And you see, I'd have been kicked out of the class now had I, used the other device that I'm using now that is giving me sharing from, that is giving me all this problem. Wouldn't have been able to do anything. All right. When you go to teacher school, them tell you say if one method don't work, you have to try one next method. So guess what? Well, this computer and the devil believe that in being cramp my style, let me show him that the good old pencil and paper still works. So let me write the question. Can you repeat the question for me, please? Y equals
7 minus x.
7 minus x squared times 5x squared minus 1.
All right. So dy by dx is going to be equal to the first, which is 7 minus x squared, times the differentiation of the second, which is going to be 10x, minus the plus the second, which is 5, right? 5x squared minus 1, times the differentiation of the second. Oh, what's the differentiation of the first?
2x.
Negative.
Very good. Negative 2x. That's why I stop and ask the question. So dy by dx is going to be equal to, wow, this looks like 70x minus 10x cube minus 10x cube plus 2x. This is going to be negative 20x cube plus 70x plus 2x. Everybody got that?
Yes, sir.
Yes, sir.
Very nice. Very nice. Who did not get that?
Sir,
Repeat that. Negative 20x cube plus 70x plus 2. That's plus 72x. Everybody got that?
So you're going to factorize it?
Okay. So negative 20x cube plus 72x, I would say, oh Jesus, what that? 4, don't. 4x?
Yeah.
Yes,
So
sir.
I use 2, but
No man, 4.
doesn't matter.
It does.
You have to use a
4,
bigger number.
right, you have to do complete factorization.
Okay.
So we have 4x minus 5x squared plus 4 ones 4, 4 8 32. So that's going to be plus 18. Everybody got that?
So I never got that because I used 2 instead of 4.
Oh, so you got 10. You got 2x into negative 10x squared plus 36.
Yeah, 36x. So I never use the 2x. I don't know
Oh,
why.
okay. But when you factorize it, let us do the complete factorization.
Sir, I was looking for a bigger number, but you see, because I was just trying to hurry up and finish, I just used it.
Fair enough.
I was trying to find a big number that could go into.
Fair enough. All right. The whole system is shutting down, so never mind. Let's just go with the quotient rule. The quotient rule. I'm going to sing you a song. Please do not laugh at my singing. Beyonce can't come close to me. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares.
Wait, sir, you share your screen or something?
No, miss, I thought because the screen don't want to share at all. The system restarted. But just listen to the story for now. I soon reshare it. Listen to the story for now, mommy. The denominator. Try and internalize it. The denominator. When I call it, I write it back. So the denominator, again, write it down. Times the differentiation of the numerator. That means I'm going to differentiate the numerator. I'm going to multiply the denominator by the differential of the numerator. Then minus the numerator times the differentiation of the denominator. And then I'm going to put all of that over the denominator squares. So it's a denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. One more time. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. Tell me when you've seen it.
Yes, sir.
Yes, sir.
Yes,
All
I've
right.
seen it.
The question that I typed was not saved because the system shut down, so I had copied question number 4, but never mind. Oh boy. So it's a denominator times the differential of the numerator minus the numerator times the differential of the denominator all over the denominator squares. Sir, you still not see it. All right, I'm happy you haven't. I will now get another opportunity to walk you through. Watch me. What clear now, Jesus? Then me must do something like this. You tell me if me all right. You tell me if you teach it all right. I'm differentiating. I mean, of y. Where's my dy by dx? Copy and paste, man. Copy and paste. But things that I'm seeing my error. All right, let's go now. All right. So my question is, yes, honey.
Sir, when you were just writing it, did you put given y equals, or you just putting in that now?
I'm just putting it out now.
Sir, say it wouldn't be wrong then too.
No. What? No, right here is where I
So
had
you had
y.
y, sir, but you
Yeah.
never put in given find dy of dx. So it wouldn't be wrong because you just had the y. So you would have
No,
just
but
continued with
no,
y.
but here so I was differentiating
Oh, so that's why I use the dy over the
by
dx.
dx. Yeah. Right.
Okay.
All right. So yes. So once I'm finding my derivative, my dy by dx, I'm differentiating y with respect to x. I must indicate it by writing dy by dx. I could also indicate it by writing f dash of x, or I could also indicate it by writing, y dash of x. But it is very important for me to indicate what it is that I'm actually doing. It's very important, extremely important that I do that. If I don't, my question is incomplete. All right. So here it says, given y is equal to x squared over 2 over x plus 2, find dy by dx. Find dy by dx. Find dy by dx. All right. Here goes my solution. My solution is, and I want you to watch me. Don't blink. Please don't blink. The denominator, not V, come, focus. The denominator, see it here, so, times the differentiation of the numerator. It means that I need to differentiate x squared. I'm going to get 2x. See it here, so, times the differentiation of the numerator. Minus the numerator, minus x squared. See it here, so.
I don't understand that.
Say it again.
So I don't understand.
Right.
How you get 2x?
Hold on. How I get 2x? No, man, you miss a class fully then, man. All right, so remember, you know.
Please tell me never there none at all.
Yeah, but, you know, you never see the notes that I post anything?
Sir, me never, to them I get back like, me not have like since Monday.
Okay, all right, got you. See, no, WhatsApp, you know, could I send my little WhatsApp message?
Sure, me call you.
You can't call. If you call me, that get through to me. You know, call me no way. I'm somebody else to call.
I'm a mother phone me use and call you don't answer. And me did a call Mr. Muirhead to say if him could I, and him don't answer either. The only teacher me get was Mr. Emmanuel.
So whenever ask Mr. Emmanuel for coming, all right, never mind. Come. Look, y is equal to x to the n. Y is equal to x raised to the n power. Y is equal to x to the n. All right, watch me. The n here so is going to go and multiply with the coefficient of x. See it here so, the n here come in front of the x here so, right here so, right there so. And then I'm going to subtract 1 from the power.
So the coefficient of x right there, so would that be 1, say that be n times 1x, and then you subtract back 1 from the n up at the top?
Yes, good. Come on, same here so. So you catch it now? Every time I saw we do it. And look at this now. So we call this f dash of x as our first derivative, or we can use dy by dx, or we can use y dash of x. So these are some conventions. In chemistry, we call it nomenclature. All right? The naming of. So these are our conventions. F dash of x is the first derivative, or I can say dy by dx, which is the same first derivative, or I can say y dash of x, same first derivative. When I move to the second derivative, I go to f double dash of x, or d squared y by dx squared, or y double dash of x, so forth and so on. F triple dash d cube y by dx cube, y triple dash of x. All right? So those are the, so when I'm differentiating, oh Lord, I think I passed it. When I'm differentiating x squared, it means that it's going to be 2 times x, which is right here. And then no, we're minusing the continuing, minusing the x squared. I hope you're following so far. We need to have a session to catch up with, for some lost time. Minus the numerator, which is x squared, times the differentiation of the denominator. When I differentiate the denominator, differential of x is going to be 1. Differential of a constant 2 is going to be 0. So the answer is going to be times 1. All over the denominator squares, which is x plus 2 all squares. My differentiation ends right here, so all that I now need to do is to fix it up. Let's go again. The denominator times the differentiation of the numerator. While I'm saying it, I'm going to say it and pause. And you look to see from the question to what I have in blue. From the question to what I have in blue, look to see if you can make the connection. Let's go. The denominator. Identify the denominator in the question and look to see the position of it in the solution in blue. The denominator. In big school, that little dot don't mean full stop. It means multiplication. So let's go. The denominator, identify it. Look for the location. Times the differentiation of the numerator. Look for the numerator in the question. Differentiate it. When you differentiate it, look for it in the solution.
And so catch me, I can't do the differentiation part.
Yeah, I kind of figured. You have to come to the class tomorrow.
Yes.
You have to come in tomorrow. Yeah, man. All right? Just go on, try follow what go on now, and then we know you have to reach in tomorrow morning. Let's go. Okay. So what I'm going to be doing, again, I'm going to call the stuff. Pause so you can identify from the question into the differential. And the differential, I just color coded it to be blue. Good to go. The denominator. Identify the denominator into the question. Look in the solution and see if you can locate it. Times the differentiation of the numerator. Go back to the original question. Differentiate the numerator. X squared, when I differentiate it, I'm going to get 2x. Look, put the 2x on beside the denominator, and you're going to multiply that. So now you see the denominator times the differentiation of the numerator. Minus the numerator. So I'm going to put a minus sign and then write the numerator. What is the numerator? X squared. I'm going to write it down. Times the differentiation of the denominator. X plus 2. I'm differentiating x plus 2. The differential of a constant is equal to 0 every single time. Yesterday, tomorrow, today, tomorrow, and the next days to come. When I differentiate a constant, I get 0. And I proved that to you already. Y is 0. And when I differentiate x, I'm going to get 1. So I'm going to have minus x squared times 1. And then it's going to be all over the denominator squares. Let me caution you. Whenever we're doing the quotient rule, we never, ever, ever, ever expand the denominator when we have it squared. So don't say, okay, sir, it's going to be x plus 2 times x plus 2, x squared plus 4, x plus 4. No, no deal. We are going to leave our denominator as a exponent every single time, barring none. The denominator, x plus 2, times the differentiation of the numerator. When I differentiate x squared, I'm going to get 2x. Minus the numerator, minus x squared, times the differentiation of the denominator. Differentiating x, I get 1. So it's times 1. All over the denominator squares, the denominator is going to be x plus 2. So it now becomes x plus 2 all squares. The differentiation ends right there. Now remember, if I'm speaking to you and my eyes are closed, I'm not looking at the screen. I don't want you to believe me. I'm not looking at the screen. All right? Why am I telling you this? Because at some point in time, I can picture what it is that I'm looking at. The denominator first, times the differentiation of the numerator, minus the numerator, times the differentiation of the denominator. Then it's all over the denominator squares. All over the denominator squares. Trust me, whenever you get a question on the quotient rule, the product rule, or the chain rule, sing your song to yourself. You can't go wrong. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. You can't go wrong. Me tell you that. You can't go wrong. Trust me. The only place you can go wrong with the question is in the algebra section of it when you are fixing it up and removing the parentheses and to factorize. But the differentiation, you must get full marks. You know why? Sing your song. The first times the differentiation of the second plus the second times the differentiation of the first. That's the product rule. The quotient rule. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. Are you all on board?
Yes, sir.
So if my catch the
Yes, sir.
differentiation part tomorrow, sir, yes.
All right, cool. Let's go. Let me go through the question now. Since the denominator, bam, up here, so times the differentiation of the numerator. When I differentiate x squared, I'm going to get 2x minus the numerator minus x squared times the differentiation of the denominator, which is times 1, all over the denominator squares. All right, watch me. I'm saying this is going to become 2x, I'm putting it in front right here, so multiply by this x plus 1 and this 1 times 2. Let me have that left. So, but and then I'm going to have the 1, this 1 times this x squared, so it's going to be negative x squared right here, and 2x times x is going to be 2x squared, and 2x times 2 is going to be 4x. The denominator remains as it is, x plus 2 all squares. We never expand the denominator. We never expand our denominator. Never expand your denominator. So this now becomes, looking for my like terms, 2x squared minus x squared is just going to give me x squared, and what is left is going to be my 4x, and that is over x plus 2 all squares. I can fix up because this can factor out. And I'll show you why it is that I'm teaching you how to factorize your answer. You will soon see why I'm asking you to factorize the answer and just fix it up. All right? So I'm factorizing my x because it's common. So I'm going to have x times x plus 4. And it's all over my x plus 2 all squared. Honestly, I think I have gone through this question like about 5 times. No, I want you to try this one on your own. You have a solution projected for the first question. That one is yours. I give you, oh Jesus, 8 o'clock on. Come on, guys. I give you a couple of minutes. Remember, I must finish product rule and quotient rule tonight, Must. Because we did logarithmic function, product quotient rule. All right. So we still have a far way to go. So come, hurry, please. Anybody finish?
Yes, sir.
Yes, sir.
Oh, nice.
Yes, sir.
What is the answer?
Sir,
What is the one?
Sir,
sir,
I
x
got
squared
x squared
minus.
minus 14x minus 3 divided by x minus 7 squared. Come here, boy.
Nice job. Everybody got that? That's what Tantan answer is. Tantan answer, my answer
Yes,
looks
sir.
alike.
Sir, I have to.
Sir, negative 3 times 1 is negative 3.
Yes, true.
Sir, say never get the same thing as me.
I put that there to see if you were paying attention, all right? That's why it was there. Just to check if you were paying attention. All right.
Sir,
Yes, Papa.
the negative we have outside of the bracket, it now for distribute or something.
And that's why I had this absolutely. And that's why I had a positive 3. Because there's a negative sign outside here, not telling you.
Oh, sir, I never know.
Yeah, man.
Oh, the negative, this, oh. So
Yeah,
it will
man.
minus x squared and positive 3.
Yeah. Thank you, Matthew. But I don't know why I have the question 2 times. You don't know what happened now. Oh Lord. Oh, it's not the same question. All right. I don't know what is wrong with my eyes. All right, very nice. I'm liking the fact that people are participating and getting the stuff. There's an example 3 there. Run with it, please. Come on. We have 10 minutes. Run with it, please. Run as fast as you can. Let me know when you're finished. How is the?
Finish, sir.
Finish?
Yes, sir.
What's the answer, Nancy?
Sir, 6x squared minus 32x plus 42 over x squared minus 7 all squared.
Minus 42 or plus 42?
Plus 42.
Oh, that's what it said? Okay. Shanti. Shanti Poo. Your swag turn up. Matthew. You can't make Shanti outdo, you know.
We get it.
John Mark. You see the boy love sleep. You not get it yet?
No, sir.
All right, hurry up. Natty B, are you able to start it? I understand that you just seen this for the first time, but are you able to start it, Natty?
Sir, me can't do the differentiation part, sir, but I can follow it. Like, I know some them.
All right, no problem. No problem. I'm just a little concerned that I'm not hearing from Tariq. Unmute from Facebook. Oh, you stay?
Sir, I'm following. I wasn't here Monday as well.
Tariq, me, I forgot about the one talk, you know.
Yes, sir.
All right, cool. Sana, Casey, oh, you stay? Sana?
Yes, sir.
Oh, you stay?
Lost?
Yeah.
So, Casey, if you never ask me to tell me?
So, we just give up on this whole maths thing, you know, but me I can try my best in the exam.
No, wait a while ago.
Yeah.
Put him up on the phone.
Good night, sir.
Jeez and peas. Mommy, how you do?
I'm okay, and you?
I'm going to put Kesana across my lap and beat her. She said she's giving up on my maths.
Yes, I realized she said it too before you heard, and I told her not to say that.
Mommy, I'm going to beat her. I love her, but I'm going to beat her.
She's about to give up the school.
No. Is she Adventist? Can she come to class tomorrow morning?
She's not Adventist, sir.
Okay, good. All right, great. So tell her tomorrow, 8 o'clock, she's supposed to be in class. So if she not wake up, mommy, throw some water up on her ear and wake her up.
Okay, 8 o'clock?
8 o'clock tomorrow, yeah, man.
All right, no problem.
Online, same online.
All right.
All right, cool.
So, I was following, until I saw the answer for the question. I realized my answer never matched it. But my answer for the other question was right, so I'm going to know.
Very nice. Very nice. What do I say? How do I say it, Lord? I know it is. All right. So the integrated math is not difficult. However, we don't have a lot of time, and as such, it seems as if I am going fast, and I'm going because next month this time your exam is tomorrow. We don't hear from CXC to say they're going to push back by a month, and the talk on the road is that the CXC wants to get back on their scheduled for exams and they're not going to give any extension. I don't get anything official from
Sir, I
CXC.
don't know if it's my Wi-Fi or yours, but the alien they might attack you.
No, man, it sounds like yours because I am, no, I'm not using data. Yeah, but I don't want anybody to give up on me, please. We don't start something and don't finish it.
So, sir, you know, factorize that.
Because I'm not going to factorize. Oh, not factorizable.
Oh, because of 42?
Sir.
Yeah. Yes, please, Tantan.
Sir, you can go, please. Sir, when you, sir, isn't it supposed to be the D, I mean? Oh, okay. Sir, what did you do? Move the 2 and put it in front of the. So you can do that.
Yeah, man, because this is multiplied by this, which is multiplied by this, yeah. So I'm just rearranging, yeah, man. I'm just rearranging. Unconventional, but me not do not more tonight. Want to talk to me? I have 6 minutes to talk. Anything.
Sir,
Anything.
sir, you did talk about the SBA, the IA on Monday?
No, let me tell you something. That in itself is just another headache. I mean, Mr. Russell and I had a serious talk today, and we're supposed to be meeting tomorrow. So when Matthew says that he has class tomorrow, I know of it because I know Mr. Russell is meeting tomorrow, a face-to-face class on campus. So I said to him that, I can't come on campus tomorrow because I'm teaching an online class with my weekend students. The weekend students are online. And I'm teaching from 8 o'clock to 12 o'clock tomorrow. So we have to go meet. You think it's alone under pressure? You think it's alone under pressure? Oh my God. So it has to be done.
Sure.
Mm-hmm.
You can chat, please.
Mm-hmm. Okay, so the chat is on. All right, so it's on this device. Yeah. I'm not doing anything else. I mean, I know you guys are tired. I know you guys are overwhelmed.
Sir, yes. Oh, don't for just tell what this week, so we have exam next week. That don't make sense enough.
So when them tell you say exam is next week?
Yeah, them say.
Yes, sir.
Yeah.
So? No, Jesus, I'm out of it.
Here's the 7th to like another day sometime.
All right, I will look at some schedule and let you know.
But sir,
guess what? Yes, Papa.
They say the exam is during our class time.
Mm-hmm.
And it's face to face.
Talk truth. So you should have asked them how
during class time home 5 o'clock
yeah, I know.
class?
But no, it can't happen like that. So we have to go set a different time for the math. We have to set a different time for the math. All right. I'll figure it out. I'll figure it out and let you know. Come, want to talk to me. Talk to me about something other than school. I need to relax in myself. Talk to me about something. Talk, somebody.
Sir, but at school alone,
Sir, school alone, sir.
School alone.
I can tell you that my foot bottom is very dirty.
Your foot bottom is very dirty?
Sir, it is very dirty.
You must wear slippers.
Sir, I wear slippers, but let me tell you what my lotion my foot bottom and then my slippers at one point. So now, when you cook food pan with stove, I say look.
That means dirty bad then, man.
Sir,
guess what?
Where you walking?
Guess what? Guess what? When I was going to UA, and we have some of them hot girls there at UA. The hot girls, and because them wear the flip flop, and especially when no matter what. I mean, when I went to UA, we had Mona School of Business wasn't there. That pretty big building. No man, it was a cow pasture. So we are on campus and we're seeing cows grazing, literal cows grazing, right? And because you have to walk in the dirt, when they look up on them foot, weren't the prettiest things. They always have a wet rag to wipe up them foot at school. But don't worry about it.
Sir, girl, don't beard. It's beard them never beard. That's why them
No man, guess what? Let me tell you something. And you may be right. Because when you go to school.
No, sir, Elisha tell me beard every day. Is that girl?
Then you ask girl, don't
guys.
Okay, all right. Let me talk about something else. Let me ask you a question. And we have 2 minutes to talk about this. So we're closing off at 8:30. What say you about this Oscar something with Will and Chris Rock? Or no feel about it? You think Chris Rock deserve it? You think Will was out of order?
I believe like him should have boxed him after the stage or something.
Yes, sir. Like
backstage.
That was very unprofessional.
Unprofessional.
He never did that for boxing.
Right, that's so. He never did for that. Right, that's so. Even if him be upset backstage, you can cuss with him backstage. Nobody needed to know.
So me think say something in a something because 90% of the persons that were there or saw it they have never seen Will act out of character. So it's strange. Sir, but I know him could I knock him out backstage for true.
Anybody else?
Sir, we need donation for social outreach.
Okay.
Yes,
Anybody
sir,
else?
me I beg your thing.
Yes, sir. Social outreach.
Sir, not to be a beg your thing for social outreach, sir.
Okay. You see? I saw come in and say, sitting around, we don't know if it's now. When you can beg teacher things, when you must go to the bankers.
Not begging, it's donations. Yeah.
Yeah. Okay. And you must go to the bankers, and you must go to the financiers and Mrs. Henningham and but anyhow, I will give my donation. I'll find me some perishable stuff.
Not to be a beg your donations for social outreach.
Thanks for kids.
Miss me, I beg you anything at all for the kids. The kids.
So you do like,
Sir, on what days do you come to school?
I am there most Mondays.
So where's the office? Because I don't even
When you be 18 years old life, sir. When you be 18 sir.
All right.
But may I say,
Sir,
sir,
describe
but
yourself.
Quesada,
Yes.
you who are promoting the social outreach, you need to say what is the outreach? What are you going to do? Which of the institutions are going to be working with? What is the outreach? Is it that you're collecting with what items? You're collecting books? You're just funding something? What is it that you're going to do?
Collecting for donations so we can buy the books and buy food to distribute to the kids when we go to the institution.
So you're collecting money, just kind money.
Yes. But
then suppose I don't have money and have
that if you know anybody that's work at like we don't call it, we can give a juice and snacks. We can contact.
Yeah, any business
Sir, if you
distributed,
don't have
please.
no money can give me, you can buy 2 cases of the liquor water for the kids. Them thirsty, them run up and down.
I love it. So when do you guys go to school on a Monday?
Yes, sir.
No,
sir.
not all of us.
No, sir.
Sir, Wednesday, Thursday. But since it's next week and we have exams, sir, we're not sure.
Wednesday, Thursday.
Every day except Friday.
You're there every day. All right. I'm there. I was there Monday. When did I speak to Mr. Muirhead? And I walked up and down on the building looking to see if I see anybody looking like Unos. Not a soul.
Sir, we always a look for
Sir,
you,
you know
sir.
how we
Every
look,
week we a
sir.
look for you,
Here,
sir.
Exactly.
I'll
like,
never find you, sir.
You
sir,
know, you always a meeting
Sir,
and
me
not
feel
never
like you have play
come.
hide and seek with me, you
Yes,
know.
sir. You, sir. Yes,
All
Sir,
sir.
right.
whoever fi
Okay. So
ask people what them name and them thing there.
sir, but you say I look for anybody who look like we, but you don't know, you know,
which is
sir,
which is
I'm here.
which is the point. Which is the point. Which is the point. So
Sir, I
because I know
remember
Mr.
one day I
Muirhead
came to
knows you.
school and I hear your
Mhm.
voice. I'm look and you disappear. I don't know where you gone. You really hide.
No, I moved very fast. I know I was there one Monday and I was with Mrs. McLeod Thomas. Then I went to Mrs. Williams. Then I went to Mr. Muirhead. Then I had to run back to Block A to deal with another math lecturer. And trust me, and that's why I ended up coming late to your class that Monday because I was up and down trying to sort out a whole lot of stuff. All right, so let us plan for one day next week. Which day most of you are going to school next week?
Wednesday, Thursday.
Wednesday.
So Wednesday.
What time on Wednesday? What time Wednesday will you guys be there?
The
Early,
whole
early,
day.
early.
The whole
Pro
day.
not even start midnight, sir. Early.
Yes, sir. First class is 8 to 10.
Which class is that?
Biology with Mr. Muirhead.
Oh,
But that's
Jesus.
face to face, but I will still be at school.
All right then. So next week Wednesday, I'm gonna go bomb rush Mr. Muirhead class.
Yes, sir. So I want to ask, when is your maths exam? I remember the date you tell me.
I will tell you. I know when my math exam is, the 2nd of May 2022.
No, not the exam, like the math exam.
When I find out, I tell you.
Sir,
I'm
we're
gonna look at the
begging,
schedule.
sir, we're begging for lenience upon it.
Sir, and send the topics to, yeah.
Sir,
Yes,
just
sir,
the last
please.
subject, no, sir.
Never kill we off.
No man, I'm just gonna be myself. I'm gonna be very nice.
So what are we going to
Sir,
get?
don't make
Like
the multiple
semester
choice
2
them hard,
topics
sir.
only?
I will let you know. But remember, your differentiation is going, your calculus is going to be there, so you have to start studying. And I have to start putting some serious work. Serious work. A thought came to mind. And I'll need to speak with her about it. I am going to see if I can, but then again, no, it may not be good because I'm going to be losing an hour. I was thinking that one of these Mondays I could exchange with Miss. No, but Miss Walker don't teach you. It's Mr. Muirhead. Which class do you have 3 to 5 on a Monday?
Chemistry.
Oh, with Mrs. Thomas. All right, let me speak with Mrs. Thomas. 3 to 5, 3 to 6.
Sir, what are you trying to schedule?
No, I was trying to see if I could exchange a class with her, and then I would meet you guys, the face to face, and then she could take this evening class. But if I do that, none of the other classes have the 3-hour session, and I'm going to be losing out, and I can't lose up my extra hour.
Sir, can try again.
When I said I can't, we can't lose out the extra hour. All right, I'm gonna be working I'm gonna be working something up because that's a thought that came to mind today. I don't know why I was thinking of Miss Walker, but Miss Walker don't have you guys because it's Mr. Muirhead. Miss Walker does the year 1 bio, and Mr. Muirhead has a year 2 bio. But I will work something out. Yes, please.
Sir, so the face to face that you're thinking about having, does it have to be on a Monday? Because like the 3 to 5 sessions, I have to be home.
You have to be home for 3 to 5 sessions?
Yes.
No, it don't have to be on a Monday, but my thing is, a Tuesday is just not good for neither Mr. Muirhead or myself because the pair of us sit on the executive and we meet every Tuesday for an exec meeting. So the challenge is my days, because of how my timetable is set up, my days are filled with a whole lot of meetings. I mean, when I say meetings, but I have to put something in place. And the thing about it is that I would have called you guys in on a Saturday to meet and we just go through some stuff, but I also teach on a Saturday morning. And I'll have to canvas one or two of the, oh Lord. Anyway, let me not speak out of turn. It is going to work out. We believe in our risen Lord. And trust me, Father God, not going to carry us this far and leave us. Is one of the things that I can guarantee you. Mrs. Henningham and myself, we have been through it. We have been through Cape, Cape or A levels. We have been through university, and we are here sharing our experiences with you. It was never easy. I can tell you, Mrs. Henningham may not have gone through that, but me, I will tell you, me in my lab already and my lab class, my product that I was making in over chemistry never come out of me. System never get 0, and I wanted to start flow. Real talk. Me just start ball. Me don't know what else to do. Me just start ball. And the lab tech said to me, "Why are you crying?" I said, "I thought I made the thing good." She said, "Did you put it in the oven?" I said, "Yes." And this is how it came out. She said, "Don't worry about it here." I said, "All right, thank you." And always she tell me, "She go help me out," me still a cry because we didn't want 5 out of 5, but we never get 5 out of 5. Right? But it is rough. University is rough. So what it is that we are giving you here now is just preparation. It is preparation for what is to come. It is rough. And I'm going to tell you, Mrs. Henningham may have had it a little differently than how we had it over. My days was Faculty of Pure and Applied Sciences. You guys are now Science and Technology. Here with the man is so wicked. We have classes ending Friday evening and exam starts on Monday. You see, when the lecturers them rush through on Friday evening, best believe are question 1 on the paper on Monday. You all right?
So then you give up? Would I give up my life?
No, man, but I'm telling you, ask anybody who went to university that era, it was rough in Faculty of Pure and Applied Sciences, and I'm going to tell you, chemistry exam Monday, bio exam Tuesday, math exam Wednesday, and then by the first week you're done. I remember once we were in an exam room and, the math students were sitting in one row because there's not a lot of us. I mean, when you do maths on campus, they may start out with about 50 students in year 1. But after them go through M10, the 100 courses, it dwindles down to about 20. So when we have exam in the auditorium, 20 of us can hold in one row, just one column of the auditorium. And I remember the social sciences students were sitting there, and somebody who was sitting, somebody who was sitting across from me said, "But hold on there, but the lecturer never teach you this." And then all you could hear is everybody so start his them teeth. And we sat down and we're looking at them. And the people them start to demonstrate inside of the auditorium, so them not doing no exam. The registrar had to come inside there and say, students, and them say, "We're not doing the exam. The teacher never teach you this. We're not prepared for this exam. We're not doing the exam." Hello, you think we could have tried that over Faculty of Pure and Applied? We have to sit down and write the exam. You know what happened to those students from social sciences? They were able to leave the examination room and that exam was rescheduled. Right? So you guys not going to have it easy, and you are science students, you're not going to have it easy. So I'm just saying to you, use this as your preparation, your preparatory work for things to come. You are going to have sleepless nights. You are going to have, you're going to go to school without lunch money. And even if you have lunch money, you're not going to have the chance to eat because you're going to have labs upon labs, and your lunch money is going to be in a pocket and you can't go buy food. You understand? So just work with it. Anyhow, I decided to take a break because I recognized what was happening. You guys are overwhelmed. And I feel guilty knowing that I've gone through 3 different concepts. I mean, thankfully, I think I've done what it is that I wanted to have complete tonight.
Sir.
Yes, honey.
Sir, for the YouTube, the screen is not showing.
You know, say, you are not the only one that say to me, my calculus students are saying, you know how disappointed I am? I sat down and I uploaded quite a bit of videos. And on Monday of this week, one of my students, calculus 2 students, called me and said, sir, I can hear you, know. I can hear you clearly, but me not see nothing. Is it the same thing that you're experiencing?
Yes, sir.
Oh my Lord Jesus. So if I go start over the whole lot, it's not easy. All right. I'm gonna see if I can. All right. Thanks for the information. Thanks. Anyway, guys, it was
It sounds like
yeah.
you need a break as well. Go take a
Hello,
nice sleep.
talk truth. Talk truth. No, I can't, because I have class early tomorrow morning. And I'm going to the
So drink
market
it
tomorrow.
to your nerves.
True, talk truth, yeah, man. When I must do well, when I do well, Mrs. Henningham will pay for all of us to go to Rio so we can have the weekend.
Sounds wonderful.
Yeah, love that.
I did not
man.
hear that.
It's all right. We all heard it. And you guys, have a wonderful rest of the evening. Get some rest, and we'll talk tomorrow morning here. I'll send you the link as soon as I get it.
So it's from 8 to when is the class?
8 o'clock to 12 o'clock, but you can leave whenever you have to run, but it's 8 to 12.
Okay. Bye, sir.
All right. Bye-bye. Bye-bye.
Yeah,
Take
9,
care.
10, 11.
John Mark, come off of my phone. Later, Papa. Take care.